Welcome back to my Devlog series, where I showcase the development on my indie game, which is going to be a 2D co-op platformer taking place in outer space. Another month has passed, and I managed to implement various different features I had planned for. Let's start right away. Last time, I worked on this thing that I don't really want to talk about. It was decent, but not yet finished. So to start off, I made some minor improvements to the enemy behavior. Do you see it? Much better. I also made it so that the AI reacts to being shot by the player, so that it doesn't just stand there like nothing happened. This way it feels more realistic and also prevents the player from simply taking out all his enemies from a large distance without any danger. I don't need those campers in my game. That being done, I moved on to designing and programming the next enemy in my game. I called it the floater, because, well, it floats. I planned for the floater to be one of the first enemies the player encounters in the game. It should be relatively harmless, slow, and more like a punching bag than an actual obstacle. So for the design it was simple. The floater should hover in the air, start following the player if he comes close, and on contact both damage the player and destroy itself. Regarding the programming, the only real issue I faced was to let it float consistently after its position was changed by knockback. So I had to recalculate the points between which it floats every time it was moved unexpectedly. But this was a minor struggle compared to what awaited me later this month. But let's talk about a few other things first. I implemented animation triggers in my code. Because of the structure of the finite state machine I use for my player, it was a breeze to put it together. I literally just had to write 2 lines of code for each state class. Unfortunately, I don't plan on making actual animations anytime soon, because I want to get the core gameplay done first, before creating and adding art assets. Of course, I still made sure the animations worked, by changing the color when an animation played. Great, another task finished. Next on the list, I wanted a health bar above each character to display itself. At first, I wasn't very motivated to do so, because UI design and UI programming are some of my least favorite things in game development. Turns out it wasn't too bad. With the help of a tutorial and a few articles about Unity's UI canvas, I had health bars in place that looked surprisingly nice. Then I quickly drew a placeholder sprite for my next enemy, which was going to be a turret. It should aim and shoot at the player. And because I love recycling, I tried using the same script I use for the player gun. This didn't work out very well. It was the moment I realized just how clunky and weird the aim script was. I mean, deep down I knew it was a bad implementation from the beginning, but I just couldn't push myself to fix it. Eventually, there was no way around it. When it comes to rotations, I thought I could simply type in the angle in degree and Unity will rotate the object magically for me. Turns out, rotations in Unity, or any 3D computer simulation really, are not as easy to work with as an untaught pleb like me would assume. Euler angles are the way we are used to describe rotation in everyday life, by giving a number of degrees between 0 and 360. Although this is super convenient because it's easy to visualize, it has a big problem in the world of computer simulations. There is a malicious phenomenon called gimbal lock. Gimbal lock is a mechanical and mathematical problem which appears when 2 of the 3 axes of an object happen to position themselves parallel to each other. Turning the object on either of these 2 axes would from now on have the same effect. This results in the object being limited to 2 instead of 3 possible axes to rotate around, which you guessed it, isn't ideal. That's why programs like Unity show us a representation of rotation with human-readable Euler angles, but process them internally with mathematical dark magic called Quaternions. A Quaternion is a four-dimensional complex number that can be used to describe rotations without suffering from gimbal lock. I make 2D games because I feel already overwhelmed by the third axis. And now Unity is throwing a fourth axis at me? Not cool. But giving up that early wasn't exactly in my interest. So I decided to learn how Quaternions work. Eventually, I didn't learn how Quaternions work. What I instead did was copying code from the internet and spending hours of trial and error to make it work. With the help of brute force and lots of determination, I finally managed to adapt the code so that it worked for my scenario. But once it worked perfectly. In the end, the code I needed wasn't very long. Unity's math functions handle most things for you. But it's safe to say that I understood almost nothing about the underlying systems, which frustrated me a lot. So much in fact that I put rotation on my list of things I hate about game dev. Afterwards, I needed to let all that anger and frustration out somehow. So I decided to build a bomb in my game. That was quite relieving. Anyway, back to the turret. With the power of Quaternions, the aiming worked great. Okay, this was fun and all, but for the end of the video I need something more than just a regular turret. You know what I'm talking about? Exactly. A turret on wheels. Oh, and by the way, I also made my own website, because it makes me look to at least 12% more professional. And that was it for the month of November. The rotation issue was among the bigger challenges I've faced so far during the development. And next time, I will try doing something even more ambitious. Adding local multiplayer.